4 light-years away from Earth is a rocky planet that may harbor life called Proxima B. While astronomers are eager to reach the planet, one of the biggest challenges to overcome in their quest is the propulsion system needed to enable both accelerating and decelerating to this distance. A firm now believes it has the solution in the form of an antimatter-based propulsion system, which it is now looking for funding to create. BAR Technologies was first funded by NASA in 2002 to perform preliminary work on its design, but it is now looking for an additional $200,000 on its Kickstarter page to advance the idea into a working concept. The idea is an antimatter thruster capable of reaching 5% of the speed of light at almost 1017 joules per kilogram. Antimatter has the highest energy of any source known to man. This high energy makes it very difficult to store, and so far no propulsion system has been designed which can convert the antimatter into usable thrust for spacecrafts. BAR Technologies' design is made up of two parts: a carbon cell that uses a uranium fuel which is connected to an antimatter storage unit. The basic principle is nuclear fission, the process by which an atomic nucleus splits into two daughters, releasing kinetic energy as it does so. In BAR Technologies' thruster, an antiproton is directed at the uranium fuel. The negative charge on the antiproton causes the uranium to fission. One fission daughter travels away from the sail at a speed of approximately 13,800 kilometers per second, or 4.6% of the speed of light. The second fission daughter is absorbed by the sail, depositing its momentum and causing the sail to accelerate. Standard nuclear rockets use hydrogen gas as thrust, but by replacing this hydrogen with a uranium fuel, it produces the needed amount of antimatter, making this the first proposed antimatter-based propulsion system that is within the near-term ability to produce. With the nearest candidate solar system, Alpha Centauri, 4.3 light-years away, the fastest current spaceship would take over 80,000 years to get there, but using the antimatter sail would reduce that time down to 90 years. The thruster could also help us reach Proxima B, a rocky planet that may harbor life just 4 light-years from Earth, in about 84 years. So far, the firm has raised $471 of its $200,000 target, but the $200,000 would only be a drop in the ocean of the price to create a working prototype. In an interview with Forbes, Gerald Jackson, CEO of BAR Technologies, said, "Crowdfunding may be a good way to show interest in the project when it comes time to find bigger investors or governmental support. We will then need funding on the order of $100 million to actually build small prototype propulsion and power systems. If money is raised, they say an antimatter-driven spacecraft prototype could be tested within a decade."